All right, kids, this is part 2. Hopefully you've gotten your second round of note sheets. We are going to talk about proving that triangles are congruent. So to start off with, we want to prove that this triangle PTS is congruent to the triangle RTQ. Now, in order to prove that triangle PTS is congruent to triangle RTQ, you have to show that all the corresponding parts of one triangle are congruent to those of the other triangle by their markings, and in this situation, probably by vertical angles theorem and an alternate interior angles theorem. So let's start with some statements. What are some things that we absolutely know? If you just look at the markings, we know that line segment PT has to be congruent to line segment TR because those both have two lines through them. Okay? Now I'm going to put a comma because there's also some other line segments that work. Line segment PS must be congruent to line segment QR because those both have one line through them. Okay? And then the last one I know, the one with the 3 lines, line segment ST must be congruent to line segment QT. Okay, so those 3 statements we can kind of make as one. And how do I know that? Because those are given. Okay, whenever we have the markings, that's a given. Okay, they showed us that by showing us the markings. The next thing that I want to do is talk about the angles. Okay, do we know any angles that are congruent? I know that this angle here has to be congruent with this angle here, but I have to name these correctly. So if I start with Q, I'm going to start with angle QTR, because remember this angle, the T has to be in the middle. Okay, now that must be congruent to, I want to make sure I find the right congruency. So I'm going to start with S, so it'll be STP. That angle has to be congruent. Okay, so it's still T and T in the middle. I know that those are congruent because of the vertical angles theorem. And we haven't really talked about the vertical angles theorem. However, and I'm going to abbreviate this THM for theorem. Okay, basically what it's saying is anytime that 2 lines cross each other like that, these 2 angles have to be equal because of the way that the lines cross. That is called the vertical angles theorem. This right here would be a very important definition, vertical angles theorem, for you to write down. Now, I also know that these 2 lines are parallel. Okay, and I know that they're parallel because of those little arrows that are on the line. Okay, so we see that these little arrows are here, so I know that these are parallel lines. Okay, so what does that mean? That means we have some alternate interior angles. I know that angle R has to be congruent to angle P because of the alternate interior angles. Okay, same thing with S and Q. Those have to be because of the alternate interior angles. So I'm going to say angle R is congruent to angle P, and angle S is congruent to angle Q. Oops, don't forget the angle symbol. Okay, so I'm just going to erase that for a second. And I'm going to get my pen to work. So angle S is congruent to angle Q. Okay, and how did I know that? That was the alternate, I'm going to abbreviate this a little bit, alternate interior angles theorem. Oof, my handwriting is nasty. It happens. So now I have proven that all three of the sides are congruent and all three of the angles are congruent. So now I'm going to write my proof, the congruent statement of the triangles. Triangle PTS is congruent to triangle. Now again, we got to make sure that we name this right. Since this is P, we got to get the corresponding angle, so it'll be R. And then it's T, because those are congruent, and then Q. Okay? And this, the reason, is the definition of congruent figures. Okay? We always have to give a reason when we're proving. Definition of congruent figures, remember the definition just means that all of the angles, the corresponding angles are congruent, and all of the corresponding sides are congruent. Now, let's look at another theorem. This is called the third angles theorem. If two angles of one triangle are congruent to two angles of another triangle, then the third angles have to be congruent. Okay, that's what we call the third angles theorem. Some other theorems. We've got the reflexive property of congruent triangles. So basically what this is saying is that a triangle ABC has to be congruent to itself. Triangle ABC. That is the reflexive property. It's basically just a reflection on both sides of the congruent symbol. Then we've got the symmetric property of congruent triangles. If triangle ABC is congruent to DEF, then a triangle DEF has to be congruent to triangle ABC. Okay? Notice that the letters didn't switch around in these, okay? But just where we placed them did. So we just switched around which triangle came first. And then the transitive property says if triangle ABC is congruent to triangle DEF and triangle DEF is congruent to triangle JKL, then triangle ABC has to be congruent to triangle JKL. Okay? So if this is congruent to this one and this one is congruent to this one, then these two outside ones have to be congruent to each other because of the definition of congruency. So let's prove one more. Okay, triangle ACD is congruent to triangle CAB. Again, I would start with the givens. We know that there are some lines that are congruent. Okay, so I would start with line AD, line segment AD, has to be congruent to line segment BC. Okay, we know that because both of those have one line on them. Okay, so then we look at the one with two lines. That would be line segment DC is congruent to line segment BA, or AB, you could say it either way. Okay, and how do I know that? Again, this is given. We also have some other things that are given. Before I do that though, let's finish the line segments. So we've got these two line segments are congruent, these two line segments are congruent. We also know that line segment AC has to be congruent to line segment AC. Okay, so this is sitting on both of the triangles. So I'm going to say, well, those have to be congruent to each other. And how do I know that? That is the reflexive property. Now, we haven't talked too much about that. We did just talk about a reflexive congruence theorem, but this is the reflexive property of congruence. It's basically just saying that one thing has to be congruent to that same thing. Okay, so now we proved that the sides are all congruent. Now let's work out the angles. Okay, we know that angle DAC has to be congruent to angle BCA. Okay, again, because these both have one line on the angle. Now the ones with two angles, that would be, or two lines on the angle, that would be angle BAC must be congruent to angle ACD. Okay, ACD, The C has to be in the middle because that has the 2 lines. And then BAC, the A had to be in the middle because that had the 2 lines. Okay? And how do we know that? That's given. Okay? That is given by the markings. Okay? Now, we just learned the third angles theorem tells us that if 2 angles are congruent to each other in a triangle, then these other angles have to be congruent to each other. Okay? So I'm going to say that angle D is congruent to angle B. And how do I know that? That was the third angles theorem. And that's right there in your notes. All right? So now I have proven that all the sides are congruent, all the angles are congruent. They said to prove that triangle ACD is congruent to triangle CAB. And we proved that by the definition of congruent figures. Okay? All the sides are congruent, all the angles are congruent. Therefore, those triangles are congruent. Okay? Now, you are never going to be asked to fully write out one of these proofs with the actual statements like we've got here and the reasons, but you may be asked to, you might be given a proof and then you have to kind of organize it so that it fits right. Like we did the lines first and then we did the angles. So you will be asked to rearrange some proofs. You won't have to write them yourselves. Okay? So now it is time to go ahead and glue in your notes to your composition notebook. And then we are done for today. So if you didn't finish the first worksheet, go back and finish that now. Also, there is an activity worksheet, kind of a more fun number puzzle that you can work on if there is time remaining in the class period. Thank you. Have a great day.